There we go. Okay. Questions? Cool. Let's get this started. All right. Hi everyone. My name is Kedwin, and today I'll be presenting our talk, which is getting good at Git or Git primer. So yeah, without further ado, let's begin. So here's our agenda for today, kind of going over what source control or versioning control really is. Then we'll be covering a basic of what Git is, and then we'll go over some basic, intermediate, and maybe some possibly advanced Git commands. I'll present you with some further resources that will be helpful for learning. And then we'll have some time at the end for questions, and I'll definitely do a live demo of all the things I've covered so that you can see it in action. So let's dive into it. What is version control? Well, we've all had this problem before where we're trying to, make changes to a file, but we don't want to lose our previous version in case our test doesn't go well. So you end up with some naming scheme like this. Kind of confusing, and sometimes you don't even know what the actual final version is. So yeah, I guess I kind of explained what it is, right? Controlling a version of some document, either it's code or maybe it's software or even like a design file like we saw on the previous slide. How it does it, how this version control system does it, well, it's kind of magic, right? It's either you have a number for each thing or some other software control to keep snapshots of things at certain dates and time, but that really depends on what system you're using. Why you would want to do version control is, well, like management for your code or whatever documents you're controlling. So you can have versioning, right, as the name might imply, so you can know which version of a document something is and which one is actually your final release, or maybe which one is the version 2 that you're actually working on. And this versioning also allows for better collaboration between with multiple group members, because now you can say like, oh, I'm working on this version. If you want to make any change, you're going to have to bump the version number. When I say bump, I mean you want to increase it. So if I'm working on version 2.0.0, my colleague might, when they make a different change, they're going to call it like version 2.0.1 or 2.0.0 rev A. Well, that kind of gets in the problem, right? Which one is the actual revision? But this is why like each version control system has a different way of keeping track of which actual version we made when we say version 2, right? So that problem does get solved in its own way, and everything kind of depends on the system you're actually using. So there are different versions of software different software tools that I can use to achieve this version control system. Now, this list I have on this slide isn't nearly close enough to be the fully exhaustive list of all of these software tools that we can use. But here's some of the more like notable ones, or like some of the ones I just pulled out from this list from Wikipedia. Yeah, it's not you might not be the greatest source, but it's a good starting off point for finding out which systems are out there. And there are two main models for software, like software solutions. The first is a centralized client-server model where all of the documents that are being controlled for all the documents that are being version controlled are stored in a central place, and only on the client computers do they have like one individual file that they're being worked on, or like maybe a small set of files that are being worked on at a time. So these systems are like CVS, which is the concurrent version systems, and IBM. Another example, IBM Rational ClearCase or ClearQuest. I haven't worked with CVS before, but I have worked with ClearQuest. And basically the general premise is, if let's say there's like a document, like a text document I want to edit, I will first log into the server. I say I will lock this file for editing. I'll check it out. So only I can edit that file. And then I'll make my changes and I'll check it back in. So then now the server knows that, okay, I've updated the document and now I release the lock on the file so that other people can now edit that file. This makes it so that any changes that I make aren't overwritten by someone else making the same change at the same time. And maybe some other systems work differently, but the general premise is the same, right? There's a central source of all the documents, right? And when each person wants to make a change, they check out a specific file or to make the edit on, or a specific set of files. Now there's also the other model, which is decentralized or distributed model, where while there might be like a central server for keeping track of all the changes, like the golden or the true, let's say, source of all these files, each person working on that set of documents checks out or has a copy of the entire document set, right, on their local machine. And some popular versions of some popular software solutions are Mercurial, which is the open source replacement for Bitkeeper, kind of. There's like Apache Subversion, if I'm not mistaken, and then there's Git, right? And this talk will naturally focus mostly on Git, but why, or what is it even, right? So Git, like I kind of alluded to earlier, is one of the more popular open source, source control tools available. It's the distributed model, so every person working on the Git repository, which is which will be used to refer to the true source, or when I say true source, I mean like the central, quote unquote, source for all of the files that are being tracked. So every client every person who works on this repository generally has a full Git, like the full copy of the Git repository. Git was written by Linus Torvalds, I think in the early 2000s. And this is the same guy who wrote the Linux kernel. Originally written because they were moving away from Bitkeeper as their source control tool because it became closed source due to some licensing disagreements, to put it simply. And then I think version 2.6.12, if I'm not mistaken, or something similar to that, was the first version that Git actually maintained. And the way that Linus Torvalds wrote Git, I say Linus Torvalds, but there was also a team working with him, used CVS, which is concurrent versioning system, as the anti-reference of what not to do, and even said it like, if there was the choice, if there was the uncertainty about how to do something, take what CVS did and do the exact opposite, and then you'll have the correct answer. Because I haven't used CVS, like I said, but apparently it was awful enough to use as an anti-reference. Anyway, so that's what Git is, but why Git, right? So it's free, so it's both libre and gratis, like I said in my previous talk. Libre, free as in free speech, gratis as in free beer, right? So free to use and free to distribute and copy and make changes. It's also very popular. Used widely. I'm sure you've heard of some names. And as far as you as a student, you'll almost certainly use it in one of your classes. If not now, definitely in the future. And if not in class, probably in industry, whether you want to use it or not. It's probably a good idea to learn some of it. But what Git is not, I have to make this abundantly clear because sometimes people get confused. Git isn't GitHub, it's not GitLab, it's not Bitbucket, it's not Beanstalk, it's not hard to, because some people get confused because, like, well, don't I need a GitHub account to use Git? Don't I need some sort of account to do something, right? As is kind of in our service-driven world today. But no, actually you don't. So kind of think of it like this. Here's something that works for me. So Gmail isn't email, right? It's not all of email because there's like different email providers, for example, like Yahoo. So kind of like Gmail and Yahoo email aren't email, just like GitHub and GitLab and Bitbucket and all the other providers aren't Git. Git, well, I won't lie to you and say Git's super easy to learn. There are definitely some quirks and stuff, but after you get the basics down, the best way to learn really is to start actually using it for your own projects. And definitely you'll encounter some issues or troubles along the way with Git, but after you get through those, actually, it's definitely going to be a good learning experience. So, yeah. With that out of the way, I'll just ask, are there any questions so far? Let's see if I can find the Zoom chat. Doesn't look like it. Okay. Cool. If they're not, I'll go into some basic Git commands. Okay. But actually, we didn't xkcd comic first because xkcd is, yeah. Yeah, so kind of poking fun at how Git is kind of like dark magic, kind of hard to learn, but yeah, let's move on. So first, Git init. So this, I guess I should clarify first, is what you would be typing into the command prompt if you have Git installed locally on your workstation. So Git init basically creates a bare Git repository into your current working directory. So basically, you're creating a repository, as in like a source or a repository, right? To track files in. So anything inside or in a subdirectory of the directory you call git, run git in is going to can be tracked by Git. And so this is kind of like how in GitHub or GitLab, or I'm just going to use GitHub as an example, right? So when I say GitHub, you can take that to mean your preferred cloud provider of choice. This is how you kind of create Git repositories using Git init, I should say, is without using the provider, right? So in GitHub or your provider, you can click the create a repository. You can get the same effect by running Git init in your local system. So now you have a file, you now have a repository. How do you make changes to whatever's in it? Well, you make changes with the git commit command. So what commits are basically you're taking some changes that you've made and writing them into the history of the repository. So your history is the set of all of the all of the changes you've made to the document, to the repository, really. And the way Git commits work is that it's kind of a singly linked list pointing backwards to its parent commit. So if I make a commit A, commit B will have a pointer pointing back to the commit A. As my previous commit is commit A. And if I make a commit C on top of, make some changes on top of commit B, and I make a commit, there'll be a commit C pointing to commit B, which points to commit A. And let's say commit A is the initial commit, right? And that's like the root of everything. So basically, git commit is taking the changes you made, checking it into the repository, quote unquote, or writing it into the history. But how do we make changes to the history? Well, first you need to add your add or git add, right? Which is basically stages or prepares your work to be committed. So you have your documents, right, inside your working directory for your Git repository. Make some changes. You say git add, and you say the file name, and then you will add that change to the staging area, which is going to okay now which is saying here's the file that I've edited. I want to commit these changes into the history, right? Of the I want to save this change quote unquote permanently, really, into the history of the repository. So on this slide, did you mention that git add will ignore, if you say, you can also use wildcards with git add, I should say, first. So that's like an asterisk, which will match everything, for example. But it won't add files matching the patterns in git ignore. So what git ignore is a file that lives in the root of your working directory, or in the root of the Git directory, inside a directory in Git. And any files matching the patterns like in the git ignore file won't be committed. So you could add, like, let's say in the git ignore I have one line that says star.txt, and any .txt files will be ignored. So if I say git add star, I won't add any files ending in .txt. This is useful for like if sometimes you have some, like, let's say I'm on a Windows system and I build something. I don't want to commit the .exe file that's generated. I can add a ignore file saying ignore all exes. So I won't, every time I build, I won't add it, like change the .exe file completely. And what I should say is that Git generally works best with plain text or plain text files. So that's like your source code generally. So because Git was built for source code management, which is generally plain text. There's a way to do there's a way to manage different types of files, like with binary files with Git, and that's called Git LFS, but that's not being covered today. Git LFS stands for Git Large File Storage. Yeah. Anyway, that was a tangent. I apologize, but yeah, it kind of goes into how Git add works. And to see which files are being tracked by Git, you can always do git space ls dash files. There's no space between ls and files, just a dash. This will list all of the files that Git knows about inside the current repository. Next command is git checkout. So this is the way to switch between different branches or to look at a specific commit in history. So if I have a branch called latest and I'm currently on that branch and I want to check, let's say there's another branch called development, and I want to switch to the development branch, I will say git checkout development, and I will be on the development branch. And then you can also check out, like I said earlier, a specific commit. So I can take a look at the repository at a specific point in time. And the way I would do that is using the git checkout. So what I didn't mention earlier is that Git produces a hash for each commit that you make into the history. And a hash is basically a kind of like a unique fingerprint of the state. For simplicity, it's like a fingerprint of a state, right? So each state should have a unique hash. And this that's like a hexadecimal string, so it looks may look something like 0D135, right? So I could say if the commit has a hash of 0D135 something, I can just say git checkout 0D135, and I'll be at that state, at that commit that's with the hash 0D135 whatever, right? So this is useful for like, oh, I want to go back in history like 5 commits and see, oh, what was this file here, let's say. Yeah, so you can git checkout for that. You can also create a different branch if it doesn't already exist using the git checkout command. So git checkout -b and whatever new branch name you want to create. So I do see a question. Why might you want to use different branches? Okay, so different branches are generally used for different things, right? So you can have one branch for release, as in like this branch will always have a latest or a working build, of the software. It might be the latest version, or it might just be a stable version that we know will work. Let's have a development branch where I'm working on it daily, and you can just check code in whether it works or not. And maybe I have a testing branch where it's kind of like a slower version of the, every few days or every time I have I think of a working version, I will, update the testing branch with all the commits, which I'll explain later, and use that to say okay, this is a branch that I think is good. I'm going to test this to make sure if it's good enough for release or something. You might also have a different branch for different versions. Because each branch, right, is a independent working set. Because remember, I guess what I didn't mention earlier is each branch really is just a pointer to a specific commit. I realize that this might sound a bit confusing. Trust me, when we get to the demo section later, you should be able to see it much more clearly. So like the different branches are you can use them as different snapshots in time, so you can have one branch for a different version or stuff like that. There's definitely a whole host of other reasons why you can use branches. I don't pretend to know all of them, but does that answer your question? Okay, cool. Next one is git clone. So git clone, as its name might imply, it'll clone a repository from a remote source. So what does that mean? So let's remember I said we have a central server, quote unquote central server for these Git repository where it lives, right? Where all the track documents are stored. So let's say a team might have a Git server for their project, and let's say a new member comes on the team. First time to get a copy of that source, what they might do is use the git clone command to clone a copy of that to their local workstation to start developing on. And the basic command syntax is git clone and then the URL to that project. So generally you will be used, like the two protocols that are supported are SSH, which is secure shell, or HTTPS, right? So this, those are two different ways to go to a server. We'll note that SSH keys, using SSH to clone repositories will require SSH keys to be set up with your Git provider, your Git server. So the syntax kind of varies for Git clone, or for the Git for what you're using. For Git clone, you're using a a Git usually there's a Git user at the Git server, and you have like an owner or like a team or something, and then the project name, and then Git clone for HTTPS, it's like a Git server, maybe like github.com / your username maybe, and then like the project name you're trying to clone, and this will create the folder called project inside your current working directory where we clone it. So that's where the copy will live. The next one, git push and git pull, are the two commands for basic commands for updating your local repository for any changes that may have happened in the remote. And then git push is for you to sync your commit to the remote server. That doesn't happen by default. When you commit, it's only a change to the local working set, your local copy of the repository. So anytime you commit, you make some commits, and then you get pushed to so that the remote server is updated with your changes as well. This is kind of the basic version, basic usage. More advanced coverage, or more advanced usage will be covered later. So I kind of covered a lot of commands, but the basic workflow. So from nothing, you'll either do a git init to create a repository locally, or git clone a repository from a server. You'll make some changes into your local files. You'll git add those changes to stage to prepare them for commit, and then you'll do a git commit to commit those changes into the history, and most times you'll write a short summary of what changes you made, and after that you'll push the commits from your local local copy to the remote server. So now that your remote server has your working your changes. All right. So a few more basic commands. Here are three of them: git show, git status, and git log. Git show generally, without any options, shows the last commit message and the diff or the patch of that commit. So basically, when I say you type git commit, you'll write a short summary of the commits, of the changes you made, and it'll also show you what changes were made in that previous commit in git show. What git show will tell you. Git status will show you the current status of your repository, so what branch you're on, what modifications you've made, what changes differ from the last commit, any changes you've staged in the current for the current commit and stuff like that. Now, git log will show you the log or the history of the commits that you've made or that have been made to the repository. Next, we have git merge. So this will merge the commits from another branch into the current branch. So let's say I'm on branch latest, right? Let's say I have, branch release, right? And I have a known good state from, let's say, the latest branch, right? I will merge git, to get the changes from the latest branch into this release branch, I would say git merge latest while I'm on the release branch. So I would say first git checkout release, and then git merge latest, and that would pull the changes into that merge the changes, into from latest into release. And when I say the commits, right, that means because to have two separate branches merge and or two separate branches relate latest and release, they would have to have diverged at some point in the past, right? Even if it's from like the initial commit. So at some point, git merge kind of joins the two back together again. And basically, when I say merge, I want to merge all of the commits that are different. Basically everything from the point where it diverged, I'm going to attempt to merge into the other branch, right? In this current branch. There are a few quote unquote what Git refers to as strategies, if I'm not mistaken, as try to merge the two branches. There is a fast forward merge strategy, which if let's say I have one branch here, right? We have the source, they two split, and I don't do any work on, let's say, release, right? Let's say it's only from the previous release. I only did work on like latest. To merge it back in, I could just, because it's just a point, like release is pointing here on the tree, and then latest might be like here. I can just move latest, move like the release branch pointer to wherever latest is, and that's a fast forward, right? Because I just move the pointer. I don't do any changes to the Git history. But a Git non-fast forward or no fast forward will also make a commit that says, okay, this commit merges. I'm going to merge all these things and add a commit saying I merged it. So that might be useful for saying like, oh, I want to like write a new message, like a git commit message, let's say, for example, that says, okay, I need to create a commit for releasing, whatever. Yeah, it's kind of maybe confusing. I will, like I said earlier, there's going to be a visualization later that will be helpful. Okay, so that covers git merge. Yeah, that covers what I had for as far as what I considered like basic or things you'll be using quite often. Are there any questions so far? Okay, cool. Next, some more intermediate commands. So first is git rebase. So git rebase, well, like its name implies, rebases your commits onto another branch. So let's say, basically it's kind of like you're doing some work on your own branch, right? And then the branch that your work was based off of, like, so the point where it diverged has made some advances. Let's say you're writing some code against an API, working on an API, and your code relies on some other code that was maybe buggy. And your branch hasn't received those updates, right? Because it's a separate, you diverged, right, from the other branch. So let's call your branch, let's call the branch my branch, and the other branch, other branch. I know, good names. So on my branch, I don't have the commits that other branch has because I've been working on my own and history diverges, right? So I don't get the fixes that that other branch has if my branch was based on other branch. Now let's say I want to keep my work that I've done on my branch. Like let's say I want all the commits that I've made so far don't affect any of the things that the other branch has. What I'll do is call git rebase. While I'm on my branch, I'll call git rebase other branch. Right, I think. So what that'll do is take all the work I've done on my branch and replay it on top of the latest commit, that on top of other branch. So what this will do is, let's say I have like 3 files, like file A, file B, and file C. I modified file A, but other branches modified file B like 3 times. So what I'll do is, what git rebase kind of does is kind of resets my work to the state that file that we were the same as. Like goes back to the point where we're the same. Goes fast forwards my branch to the other branch, and then replay my changes on file A on top of the state that file A is in other branch. So file B has been changed the same 3 times on my branch, but now file A is also changed the way I changed it earlier, right? Kind of, yeah. Anyway, maybe I should stop doing these explanations and just talk through these and show you later. So git reset and revert next are the closest thing we'll get to a git undo, because if I didn't make it clear enough earlier, there is no such thing as git undo. Anything you do, any commits you make are permanent, for the most part. But for all intents and purposes, git commits, after they're done, after you commit them, they're effectively permanent, and especially if you're working with public repositories, say on GitHub. So let's see, the first command we'll cover is git reset. So git reset will move the pointer on your current branch back to whatever commit hash you specify. That can be any commit hash, but it has to be one that's validated, that's actually in your history. So that's what it'll do. And so basically anything, if you have like a series of 4 commits and you reset to like the second commit, the third and fourth commits, as far as like where your head or the location the point you're looking at, those third and fourth commits don't exist. They still exist in the Git history, but they don't. You can't see them, right? Because your current commit doesn't have a pointer going forwards to the next commit. It only has the current pointer backwards to the previous commits. Now, the other way to change, is git revert. Git revert basically, remember when I said earlier there's a diff or a patch? So it's like kind of the plus minus, like what you added, what you removed from a file. Git revert will do the opposite of that. So if you added some lines, it'll remove those lines, but if you remove some lines, it'll add them back. So git revert some commit hash will apply the inverse patch of the commit hash to the current, to the repository, like the working state, right? So whatever head is pointed at. So, and git revert, I think, if I'm not mistaken, will create another commit to change to apply the inverse patch. Next, git push force with lease. Yeah, this is the dark side. Don't do it, because sometimes you may have messed up. Maybe you did git reset and you made some more commits. Now you want to push those commits. Git doesn't like that because technically there are some other commits that maybe already exist on the remote, that have a same parent. Like, because when you have a linear history, but you reset it. Now you did some more commits. Now these commits are here that have the same parent as these 2 commits have on the server. So this doesn't reconcile, right? Because you can't have the same branch have 2 sets of commits with the same parent. So Git doesn't like that. So you can say, okay, I really want this, these new commits to replace the ones on the server. So you can do a force, git push force. So that could overwrite your work. It could overwrite someone else's work. So this is why you generally don't want to do git push. To resolve that issue, right? Maybe you both, you and your colleague, wanted to really meant to edit the different files, or you would maybe do a git pull first to pull those changes back to your remote, to your local copy, and then, or a git pull or git rebase, right? Git pull rebase. And then, make the changes, make sure you resolve the conflicts, and then push up. What the difference between force and force with lease is it kind of gets, is that force with lease is nicer in that it's basically saying, I want to force push, but only if if there are no changes made, like if no one else force pushed. I kind of don't do a good job explaining, but that's kind of the gist of what it does, right? If someone else already did a force push, I don't want to overwrite their force push with my force push. So it's kind of being nice and a little more safety with something that's kind of dangerous. Next command, we have git submodule, and this is the last kind of intermediate one I will specify for today. It basically nests another Git repository inside your repository. So it's generally good for, let's say you have a dependency or like a module you're using for your project, but let's say that module gets 6 updates a day. Kind of a lot, but that's it. But maybe they just do update that fast. But then you can't keep up with all the updates, so you want to lock this dependency at a certain state, right? Certain version. Because Git, like I said, is just a bunch of commits, right? That have pointers back to the parents. You can just say, I want to use this specific commit of this version, this project, and I will use that as, I'll just add this, version and all of its parents, right? Because it's a Git history, into my repo or repository, right? So I'll use git submodule add, and then usually the URL of the module you're going to include. If you're cloning a repository and you forgot to do git clone -- recur submodules, you will use the git submodule update -- init will update the submodules inside your directory or inside the git directory, inside your git repository, local git repository, to basically update your local submodules to actually take in the code as well, because git submodules kind of work as just a pointer, right, to another Git repository. If that makes sense. And then if you're working on a repository already, and the remote submodules might have updated, like changes on the remote server, right? You can do git pull -- recur submodules, and that'll update the modules inside your working directory as well. Questions for the intermediate commands? Okay. Moving on to what I would consider the advanced or less frequently used commands. So, first one is the interactive rebase. This kind of is the time machine I was alluding to earlier, where you can go back and rewrite history. The way I was taught or explained to me was you need to do git rebase -i for interactive, and then you want to pick a commit to base how far back do you want to go. So you specify one, and then it'll say that you say git rebase -i, and you provide a commit hash usually, and then Git will pull up a list of all of the commits since from that hash, and then up to now, and then you can do a few things, right? Here are some of the operations you can do. You can reword, just change the commit message. You can edit the commits to even just change what was committed even. You can squash, which is push, make two commits, one commit or a few commits into one commit, right? And then you also put the commit messages together. You can fix up, which is just you could drop the commit message, but you can just smash two commits together. This can help you get rid of the, I made a typo, and you have the fixed typo commits. You can also delete commits from the Git history. So yeah, this is kind of a powerful thing you can use, but like I said earlier, it's not. When I said there is no git undo, there really is no git undo, especially for commits that you already pushed to a remote server, and have already been propagated down to someone else's workstation, because it just gets really messy, and I don't understand. I don't even pretend to understand how that resolve that. So Yeah, while I do say that you can drop commits or delete commits from history, this doesn't save you from things like, oh, I committed my API key and I pushed to GitHub. That API key is now burned. What I mean by that is, don't even try to use that API key again, because um, as soon as you realize that you've committed the API key, please just go and revoke it. It'll save you a lot of pain and a lot of money probably later, because there are bots that just go out there and just scour GitHub for committed keys. Um, and even if you delete from your history, remember that Git is decentralized. And if I clone your repository with the key in it and you delete it, it doesn't matter because I don't have to clone your newest one that gets rid of your key. I still have that copy with your key in it. So even if you do interactive rebase and drop that commit and delete it from history and remove every reference to that key, I still have a copy of your key inside my copy, right, in my repository, my local working copy, right? So this is a tool that you can use to, drop certain, maybe like I included a file I didn't mean to that just never got used, or maybe I have some spelling mistake or I don't know, formatting issue. This is a good way to change those types of history, but it won't save you from things that have already been pushed out there, because there are bots that will just find the history and keep it. So yeah. Anyway, moving on. Git bisect. Git bisect is for basically a tool that helps you do a binary search on your Git history to find when you introduced a bug. So basically the way you use it is, if your current version is bad, probably is why you're using it, you say git bisect bad, right? Like literally git bisect bad. It'll mark this commit as a bad, this version, I messed up, something went wrong. But you probably know that hopefully your code was in a known good state. And that's kind of the requirement, right? You have to have a known good state and a known, your current state is bad, probably. So you say git bisect good, and you'll specify like that known good version. I think you can specify a hash, you can specify a tag, even. And what that'll do is Git will basically, take that range from the good commit to the current one, which is the bad one, right? It'll pick out something in the middle, and then it'll say, okay, at this state point, what you as the developer should do is take the current state, go compile it, do run your tests or whatever, and then you can say, okay, is this version good or bad? You know if it's good or bad. So you can say, if it's bad, you can say git bisect bad, and Git will go back and do a binary search again between this state and the previous good state and the good state, and it'll go find another commit in the middle, do the same thing. If it's good, you can say git bisect good, hit enter, and then it'll pick a version between this and the latest version, right, which is bad. So it'll keep doing this to help you narrow down exactly where in your history you went wrong. After that, you can figure out what the bug was. Hopefully you know how to fix it, and you can type git bisect reset, and that will reset you back to the state you were in, right? So generally that'll reset you to the bad state. So you probably took notes on how to fix the bug, so now you know exactly where to go. Questions on those two, what I considered advanced techniques? Okay, it doesn't look like it. So we'll be moving on. Okay. Visualization tools and resources. So here are kind of the two things I covered, or a few things I found that were pretty good. So first is gitschool.github.io. So this is, I think GitHub actually made this tool to show off how to basically help people visualize, some of the Git commands, how they're being run. It's not a fully featured Git client, so it won't actually show you every single command. But it's a good starting point. You can also use some other GUI tools, right, for managing Git repos. I am personally a fan of Git Ahead, which is available for Linux, Windows, and Mac OS. So it's very cross-platform, and the user interface is consistent across all three. I know GitHub Desktop is for, I think it's available for Windows and Mac OS at least. I'm not too sure if it's available on Linux just yet, but this is especially good for using GitHub as your source control provider. Source tree is from Atlassian, which makes Bitbucket, right? And I believe that is also a good tool for Windows and Mac OS. There are some other tools out there. I'm sure, like Git. You can always use the command line. There's also Git Cola, I believe is Git Cola actually, yeah, is another tool available for Windows, Linux, and I believe Mac OS as well, as visual Git client, which GUI Git clients or graphical clients for Git are other ways you can use to do the exact same commands I showed you earlier, but maybe in a more user-friendly format. And I'll definitely go over these in the demo. Here are some other tools that you can use to, or other links really, rather, or references. So after you install Git on your system, you can use git help and type the command you're looking to get help on. So let's say I want more help on maybe the rebase command I was talking earlier. I can say git help rebase, and the command will show up, and I can I can read about it, right? Here are some other tools. Tools or other links to references that are good. I found good. GitSCM.com is actually the source where you download Git for your computer. If you don't want to you're wanting to use like a GitHub or something. Yeah, so here's some other links. I won't explain them all, but GitHub makes a few good ones. Atlassian also makes a few good ones as well. Now troubleshooting. Yeah, something is definitely going to go wrong eventually, sometime or another. Here's another shameless plug. Join our Slack. We'll be helpful. We'll be willing to help you debug it. There are also one really link I found kind of helpful, funny, for when stuff goes terribly wrong. Oh shit Git, or dang it Git, for no swearing. But yeah, two other sites you can use or one site or two places really you can go to get some help with Git. So yeah, that's all I had prepared for the talk section. So keep in mind that source control allows you to better manage your documents, more specifically in our case, source control. And Git is probably one of the most popular, if not the most popular, tool to use. And to get started, go to git-scm.com to install Git on your local system. Available for Windows, Mac OS, and Linux. With that, are there any questions? Cool. Doesn't seem like there are any. So that concludes the talk section. For those of you watching on YouTube later, there will be a link in the description to the demo portion of this. So yeah, thanks for watching.